inertial navigation systems, which combine GNSS and IMU sensors to provide position, heading, motion, and timing information. So we have our AB200 product, which has been designed for autonomous driving applications, where it can be integrated into the sensor stack of the vehicle and provide localization information for the route planning and guidance systems. We also have our RT3000, which has been a staple in the automotive testing and validation market for over 20 years now, where it's used as a ground truth reference system for the validation of other onboard sensors and ADAS systems. So lately we've really been focused on trying to address the challenges of automated driving, in particular level 4 systems where the absence of a human driver really means the sensors have to be up to performance. Upcoming releases we have planned include working on our PTB capability, so expanding that functionality from just a master clock to also slave functionality. So for the environments where we can't provide GPS time as a master time source, instead we can synchronize with an external clock and be able to make sure all the various sensors and systems on the vehicle remain synchronized. We're also looking at timing problems in general. So for example, looking at indoor-outdoor transitions and how to manage that when you're switching between GPS time as a source and then internal time. Some of the biggest challenges are really in how to maximize the operational domain for the autonomous vehicles and maintain a high level of confidence in the localization solution. So for us, that really comes down to GNSS denied environments. So for example, urban areas with tall buildings and tunnels, industrial areas with large metallic structures like shipping containers, or completely internal environments like warehouses and depots. So in those kind of situations, you need an alternative source of information to GNSS in order to minimize the error growth that can occur when you're just relying on pure inertial dead reckoning. So that's really the idea behind our generic aiding data interface that we developed, which is we built a framework to allow us and also our users to be able to use external sensor data, many of which are going to be on the vehicle sensor suite already, and fuse that in to our existing navigation engine. So for example, using LiDAR SLAM data to provide positioning information, or getting velocity information from a visual odometry camera system, and using that to improve the localization and augment the solution so that in the situations where GNSS isn't available, you have these other sources of information to be able to maintain a high level of accuracy and reliability in the localization. So our systems output a number of confidence and integrity measurements and metrics. So the Kalman filter, which is a statistical algorithm that tracks the state of a system over time, it can calculate an instantaneous reflection of the system's best estimate for its accuracies for various measurements such as position, velocity, heading, those kind of things. And the inputs that go into that estimation include things like the data quality of the various data sources. So for example, whether the GNSS is in RTK positioning mode or not. The level of agreement between the independent GNSS solution and IMU solutions, and also the IMU error models that have been determined in our factory calibration procedure that all of our systems go through before being sent out. And then to validate that the reported accuracies from the system actually match reality, we perform a number of validation tests and using industry best practices to validate that. So these include things like extended duration static tests, dynamic tests where we can artificially blank the GNSS input and monitor the error growth that way, using known control points to measure the repeatability and the precision of the system, and then also processing the data set forwards in time and backwards in time, and comparing that to see the two independent measurements for each given epoch.